This is Unit 8, Area and Solids, Lesson 8.3, Arc Length and Sector Area. Don't forget to get a parent signature, the date, time, and location that you are watching this. Let's go ahead and review what we did previous class. You should have your reference booklet available. I would have these 2 pages of your reference booklets handy. So find these 2 pages in your reference booklet, please. It says, an area of a regular pentagon has an apothem of 8 meters and an area of 232 meters squared. Find the length of a single side. I'm going to give you a minute to get as far as you can on this on your own, and then we'll see how far you got. Ready? Go. You are allowed to use a calculator. Okay, remember the key to doing this is visualizing what you do have. It says we have a regular pentagon. That's a 5-sided shape. 1, 2, 3, 4, 5. It's regular, so all the sides are equal. Has an apothem length of 8 meters. Center to midpoint, that's 8 meters. Notice I'm crossing stuff out as we go. It has an area of 232 meters squared. I want the length of a single side, so I want this length, which we're going to call x. Let's start by writing the equation. Area equals perimeter times apothem over 2. Ready? Circle, plug, chug. Area. We actually have area. We're going to circle it, plug it in. And our area is 232. Our perimeter, that's the problem. We don't have the perimeter. But we do know our perimeter here is going to be 5 times whatever our x is. So I'm going to write 5 times x. That's our perimeter, meaning our side length, times our apothem, which is 8, over 2. From here, we cross multiply. I'm going to bring this over. And so we basically have here, we have 232 times 2 divided by 40. And we get our side length is 11.6. You were allowed to use a calculator, so don't freak out with the decimals there. All right. Now we're going to talk about what's called arc length and sector area. By the time you're done today, you're going to know about circle area, circumference, arc length, sector area, central angle, and something called theta. You need a pencil, colored pens and pencils, and a calculator. Let's start with something simple here. We have a circle. We want to find both the circumference and the area of the circle, assume the radius of the lemon slice is 3 centimeters. So let's actually draw that in. So that's 3 centimeters is our radius. I want to find circumference and area. So remember our two equations. C, d pi, I c d pi. C, d pi, I c d pi. Apple pie is really, really good. Apple pie is really, really good. So C equals d pi. And apple pie is really, really good. So I trace this out. Remember, never ever trust your eyeballs. Your diameter is not 3. Your diameter is 6. So C equals 6 pi centimeters. Here, our radius is 3. So our area equals 9 pi centimeters squared. Simple enough. Circumference, which is the length around the edge, that's circumference. And of course, area is the inside. Keep that in mind as we go on. Now, arc length, the concept of arc length. Arc length is simply a piece of the circle's circumference. Arc length. When we find arc length, the arc length is simply a fraction of a circle's circumference. It's a piece of the circumference. Length, write the word length here. Now, be very careful. Length and measure are not the same thing. For example, if this is 120 degrees, I could say the measure of the arc PQ, the degree curvature, is 120 degrees. But that is not the same thing as the actual length. You'll understand that more in class when we do a little experiment. So for now, just realize when we talk about arc measure, that means the degree curvature. And length is a piece of the circumference, and they are not the same thing. Very important you understand that. Length, if I want the length of PQ, the arc, the degree, if this was 120, the degree would be 120, but the length is going to be the physical piece of the circumference. And to find length, fraction of circumference. Just remember, fraction is simply a piece of something over a whole. It's a fraction of circumference. Use a capital C there. Now, the way you actually get that fraction is you use that central angle that we'll call that theta, whatever it is, theta over the whole, which is 360, times circumference, which is d pi. So when I want arc length, it's a fraction of circumference. Theta over 360 times d pi, which is circumference, fraction of circumference. Now, sector area, that's just a fraction of the area. Now remember, fraction is simply a piece over a whole times the area of a circle. It's a fraction of. Of means multiply. In this case, our piece would be theta, which is our central angle. over our whole, which is 360, times area, which is pi r squared. This will make sense as we do a couple examples. Okay. In the circle below, you're going to find the degree measure of the arc AC, and then you're going to find the arc length AC. The radius is 10 centimeters. Now I'm going to cross this out. We just said radius length. Now look very carefully. Measure of arc, length of arc. Not the same thing. Watch very carefully how we do this. Measure of an arc, M-E-A-S-U-R-E, and length of an arc. They are not equivalent. Watch very carefully how I distinguish those things. Ready? Okay, step number one. We do know this. If I want the measure of the arc AC, the measure, notice I'm emphasizing the word measure. We do know this. Measure of a central angle to its arc, the same. Hopefully you said that. So the measure of the arc, A to C, measure is 45 degrees. We're talking about the curvature. That's measure. When we say measure, we mean degrees. Now, if I want the actual length of the arc, the physical length of the arc, the length of an arc is actually a fraction of the circumference. So if I want to find the circumference, it's going to equal d pi. So in this case, the circumference of circle B, our diameter, is going to be 20 pi. So to find the actual length of the arc length, it's a fraction of circumference, fraction. We do 360 theta over 360 times the circumference, which is d pi. Looks like this. 45 over 360, that's fraction, times 20 pi. I know 45 goes into 360 8 times, so there's two ways I can express this arc length. It's going to be 20 pi over 8, or I can reduce that by 2. That's going to be, actually I can reduce that by 4. It should be 5 pi over 2 unit centimeters, or I can even go like this, 5 times 5 divided by 2, take it to the second decimal place, 7.85. That's arc length. Arc length is fraction of circumference. Now we're going to do the same thing in the circle below. We're going to find the sector area. Now sector area means the actual area. Again, the radius is 10 centimeters. A sector area is simply a fraction of the circle area. So first we find the area of circle B. which is going to be apple pie, is really, really good. So that's 10 squared times pi, that's 100 pi. We already found our arc length, that was 5 pi over 2 centimeters. So our sector area, you write your equation out, theta over 360 times pi r squared. Theta is 45 over 360 times 100 pi. I'm going to reduce. This goes right here 8 times. So my sector area, we can express it like this. 100 over 8 pi centimeters squared. Or reduced by 4, that's going to be 25 pi over 2 centimeters squared. Or I can show it as a fraction. 25 times pi divided by 2. Take it to the second decimal place, 39.27 centimeters squared. That's sector area. So what I want you to do is I want you to do this page, try to do it completely on your own. I'm going to set the timer for 5 minutes. If you finish early, go ahead and zoom through the video until you hit the end of 5 minutes. But I want you to finish this on your own. This page in 5 minutes. Go. Okay, let's see how you did here. So step one, it said trace the arc, EGS, so that means go the long way around. And that is, and we want to find the degree measure of EGF, and we already have that. That is 285. Remember, the word measure is the same as degrees. Then we want to find arc length. And to find arc length, that's theta over 360 times d pi. That's fraction of circumference. So it's 285 over 360 times, we have 9 there, so it's going to be 18 pi. And then you reduce as far as you can. I know 18 goes into 360 20 times. So I have 285 over 20 pi. And I know that that's going to be 57 over 4 pi, or 14.25 pi. And that's yards. That's the arc length going around this way, 14.25 pi. Now sector area is theta over 360 times pi r squared. So our theta is 285 over 360 times 9 squared times pi. And then you reduce. So I'm going to go 285 times 81 divided by 360, and we get 64.125 pi yards squared. Go ahead and go to your geometry reference folder, and let's fill out these two equations right here. So on this 2-page, arc length, that's a fraction of circumference. So that's theta over 360, and circumference is d pi. That's to find the length of an arc. And sector area is fraction of area. So that would be a theta over 360 times pi r squared, because that's fraction of area. Now, what I recommend is as you stop this video, take 2 minutes and verbally recap what you have learned in the past half hour.